Hey everybody, today what we're going to look at is the logarithm function. Now you might have been introduced to this one in grade 11 by your teacher, maybe not, but we're going to go through it all right now. So basically what a logarithm is, it's the inverse to an exponential function. So you might recall from earlier in grade 11 of the exponential functions that we see down below, where we have y is equal to 2x, y is equal to 3x, and y is equal to half x. And we see what happens when the base is bigger than 1, and when the base is smaller than 1, the graphs look a little bit different. When we deal with the inverses of these, now remember the inverses, we can make the equations by changing our x and y values. That would be the inverse. The inverse of the second one would be x is equal to 3y. And for the last one, the inverse would be x is equal to half y. Those are the inverses. Now, what do the graphs look like? Now, if you remember anything about inverses, graphs are reflected over the line y is equal to x. So our inverse of the original function would look something like this. The inverse of the second one would look very similar. And the inverse of the third one with the base of half, it would end up looking like that. Right, reflected over that line, y is equal to x. Those are the logarithms. They're written in exponential form up here, but we're going to talk about what the logarithm form of those red equations look like. So, now first part just goes through what I said. A logarithm function is the function of or the inverse of an exponential function. Its graph is a reflection of the exponential function over the line y is equal to x, which is true for all inverses that we learned in grade 11. We see that over there on the right side. So, the logarithmic equation, in the exponential function f of x is equal to 2x. The input is x. The input is our exponent. The output is the part that's by itself. So if we're trying to evaluate something with an input of 3, we're just trying to evaluate like 2 to the power of 3 or 2 to the power of 4. And we can put that into our calculator and get a y value or an f of x value for it. For the inverse, if I was to write it out, we have x is equal to 2y. If I say, what is the output, x, when the input is 8, for example, we would be trying to solve this. X is equal to 2y, right? We're inputting the other value. So we're essentially saying, what is the exponent on 2 that would result in 8? Now you might look at that and say, well, I know that y is equal to 3 because 2 to the power of 3 is 8, and that's right. But how do I do that without using, trial and error? What if it wasn't a nice whole number like 3? How do we do that? How do we use our calculator to evaluate that? That's where we learn about logarithms. So, the inverse of this function has the equation x is equal to 2y. Notice that for the inverse, the output is the exponent. It asks what exponent produces this? Typically, we could rearrange that formula to isolate for y. However, since y is an exponent, we must introduce logarithms in order to isolate for y. So this is where we get into the important part. We have our function x is equal to 2y. Now that was the inverse. We can write that in a similar format in its logarithm form. Y is equal to log 2x. Now look at what we have here, y. Where is that? Well, that's the exponent. Now it's isolated in that form on the right. Log of base 2. So it's a little 2, kind of a little subscript on the word log. That is 2. That's the base. And the last part, the x, that's called the argument when it's written in this form. That's the value that's by itself. That's our input. Right? When I said we're inputting 8, what is y? And you said 3. Now we're inputting 8. So we're going to be evaluating y is equal to log 2, 8. That essentially says 2 to the power of what is equal to 8. Here we can't isolate. In logarithm form, it's isolated. We could put that into our calculator, but we'll get to that shortly. Therefore, when we have an expression y is equal to log ax, this means that y is the exponent that must be applied to the base of a to obtain the value of x. That's what logarithms are. They're just a word. They're not variables, log. It's kind of like sine, how it goes with an angle, cos goes with an angle, or tan goes with an angle. Log goes with a base and an argument that should be with it. So it might be log 5, 12. And we're saying 5 to the power of what gives me 12. Right? And you can imagine ones like that. It's not a nice whole number because 5 to the power of 1 is 5. 5 to the power of 2 is 25. So it's somewhere between 1 and 2. And we'd need our calculator to evaluate that. So let's keep going. This just recaps. If we have this function here, its inverse can be written in exponential form, like we see here, or in logarithm form, like we see here. Both are exactly the same. They just have different forms with different variables isolated. So the inverse of that original function at the top, when in exponential form, has x as its variable that's isolated, and in logarithm form has y as its variable that's isolated. So exponential form and logarithm form, you can switch back and forth between them to isolate whatever variable you want. So an exponent of a number says how many times to use the number in a multiplication. For example, 2 to the power of 3 is 2 times 2 times 2 is 8. You know that already. A logarithm goes the other way. It asks the question, what exponent produces this? A logarithm is the exponent that must be applied to base a in order to get the x value. So 2 to the power of what is equal to 8? Like we said above. So what we're going to do is we're just going to work on going back and forth between exponential and logarithm form and then solving a couple of logs. So write the following in exponential form. If we have log 3x is equal to 9, and I want it in exponential form. Remember, exponential form is like this. A y to the power of x. So let's go with that. So our base, what is our base? Our base is 3. I can identify it. Our exponent when written in log, where is that? Well, that's 9. 3 to the power of 9 is equal to x. That's the exponential form of that logarithm that's written above. We can solve that. I can put in 3 to the power of 9 and get x, but it didn't ask us to evaluate. It just wants us to write it in exponential form. Same goes for the next one. Find my base, 2. My exponent, 5, is equal to y. I can put that in my calculator. 2 to the power of 5 is y. And finally, the last one. Notice y is not isolated in any of these, but we can isolate it by writing an exponential form. Base is 5, exponent is 2, it's equal to y. So 5 to the power of 2 is equal to y. Right? We're isolating for a different variable by rewriting it in exponential form. You're going to see, for example, 2, that we're going to isolate for the variable by writing it in logarithm form. So write the equation of the inverse of each of these exponentials in exponential and logarithm form. So it wants the inverse of them. So the inverse of this original function is x is equal to 3 to the power of y. Now it says write that in logarithm form. Right? This is the original function at the top. This is the inverse in exponential form. Now I want the inverse in logarithm form. So I look at this and I say, well, the base is 3. So that tells me that we have log 3. The exponent is y, so it's going to be y is equal to log 3 x. That's the inverse, right? This is inverse in exponential form. This is the inverse in logarithm form. Right, the original function's at the top. So let's go for the next one. Same idea. It's actually the exact same one. So let's maybe change that one up. Maybe I'll make it 5 to the power of x. If I wanted to write that in exponential form, or in the inverse exponential form, x is equal to 5y. And the log for that is y, the exponent, is equal to log the base x. And last one over here, same idea. When I'm writing the inverse in exponential form, I just change x and y. That's all that we do. And when I write the logarithm form, the exponent is equal to log of the base. Now the base is 1 over 10 x, right? This is like the number that goes after. You don't multiply x and 1 over 10. It's just the notation for it, just like when you have sine, x. You're not multiplying sine and x together. It's just the notation for where it goes. So we're looking for the logarithm of base 110 x. All right, let's go through these. Evaluate the following. So I want to know what this is equal to. To evaluate this, I'm going to say, well, let's suppose this is all equal to y. How would I evaluate that? Well, we haven't gone through how do we use log for our calculator just yet. But if I'm evaluating this, I can say, well, in exponential form, this is 5 to the power of y is equal to 25. Well, what is y in this case? Trial and error is y is equal to 2. That's what we use for our first section, trial and error. Next one, let's suppose that all of this is equal to y. We have 3 to the power of y is equal to 27. Well, what could y be? Well, 3 to the power of 1 is 3. 3 to the power of 2 is 9. 3 to the power of 3, 27. Another way that we can go about these, and another way to think about it, and I'm going to erase them here, is to take the side, like 5 is equal to y, take the right side and say, well, I want to write this as base 5. 5 to the power of what is 25? 5 to the power of 2. Therefore, y is equal to 2. Kind of the same idea as what you're thinking. Same goes for the next one. 3 to the power of y is equal to, well, 27 is 3 to the power of 3. So therefore, y must be equal to 3 because the exponents match with the same base. That's going to be something that's going to be important to us later on, so kind of a good habit to get into. That's why I wanted to introduce it here. And lastly, let's suppose this is equal to y. We have 2y is equal to 1 over 4. And I want to write 1 over 4 with a base 2. Now, if I look at this, I see 4 on the bottom, so that means we're going to have a negative exponent. And it's 4, so that's 2 squared. So it's going to have negative 2. Right? And maybe you say, how did I get there? You might say, well, I want base 2 of everything. So 1 over 2 to the power of 2. And I know that when we have an exponent on the bottom, well, that's negative. So that means y is equal to negative 2. So that's kind of the introduction to exponents. Gives you an idea of exponents and logarithms. Gives you an idea of what they are if you haven't seen them before. They're just another way of writing exponential form, and they're used for the inverse of exponential functions, but just another way to write exponential functions, basically. And that's that. If you have any questions, let me know. There's a few down here at the bottom. 1, 2, and 4 to 10 on page 451. Give it a shot, and if you have any questions, let me know.